So let's now look at an example involving a displacement of an object placed under or at the bottom of a given liquid. So we have here two questions at hand. We shall begin by solving number one. To say that an object 6 centimeters below the tank of water of refractive index 1.33, and then they are telling us to determine the displacement of the object to the observer directly above. So we shouldn't forget that now they have given us 6 as the depth of the tank, and our formula is that displacement is equal to the depth into 1 minus 1 out of refractive index. Okay? So if we are to determine the displacement, how far it will move from the actual position, we shall say, given here is that T is 6 centimeters. Refractive index is 1.33. So it is just a matter of making a substitution and say my D equaling to 6 into 1 minus 1 out of 1.33. So, and then we just now take use of our calculator and then see what actually will come from that. My calculator is telling me the displacement should be equaling to 1.4887. 1.4887 centimeters. So you can make conclusion and say the displacement of the object will be 1.4880. Therefore, the displacement is 1.4887 centimeters. So that is how far it will move from the boat. It will appear to have moved upward through that distance there. What we are calling the displacement. And then we can go to number 2. We can now go to number 2. They're saying that a tanker contains slabs of glass 8 centimeter thick and of refractive index 1.52, and then above this is a liquid 10 centimeter thick of refractive index 1.45, and floating on it is 3 centimeter of water of refractive index 1.33. Find the apparent position of the mark below the tank. It is really very important. It is really very important for us to note this, that if we are to look at displacement resulting from different materials, okay? If you're looking at displacement resulting from different materials and object placed below, but there are a number of different materials of given thickness above it, the resultant displacement is equivalent to the total displacement, okay? The sum of the displacement of each material that you look at it. How much will this material displace? How much will this one displace? Plus, so you keep on summing the displacement of every layer of material you sum and you get the total displacement. That is number 1. And then number 2, you should also note that how much an object will be displaced is independent of how far it is from the other. It is below the bottom. Like if I have this, if someone is sitting here, the position of the object this side will not determine by how much will it be displaced. Displacement is only affected by from D equaling to T into 1 minus this. Displacement is only affected by thickness of this. and it's not affected by refractive index. It doesn't matter either the object, even if you put it here or bring it close, that position does not actually affect the displacement of any object. It only depends on the thickness and the refractive index of the material. That is note number 2. Note number 1, I said that if we have different materials that is on top of the object, the resultant displacement will be displacement of each of the material layer. So let's see what we are trying to mean in what we have said. They are saying that a tank contains a slab of glass. If this is my glass, and they have told you that the slab of a tank contains a slab of glass 8 centimeters thick. That is the depth of that glass. This is my glass, and I've said refractive index is equivalent to 1.502, and then I think that above this is the liquid 10 centimeters thick. Here above this glass there is a liquid here, so this is a liquid. Its thickness is 10 centimeters. Okay, that is 10 centimeters. And then the refractive index of the liquid, above this is the liquid of 10 centimeter thick, refractive index 1.45. And then they're saying that, and the floating on it is 3 centimeters of water. There is water here. Thickness has been given by 3 centimeters. And the refractive index of water has been given as 1.33. And then they're telling you that find the apparent position of the mark below the tank. That if we place an object here, what will be the apparent position or the apparent depth? So to know the apparent depth, it is very important we first know displacement, and then you say using displacement equaling to t into 1 minus 1 out of n, and then total displacement will be displacement due to water plus displacement due to the liquid plus displacement due to glass, and that will be equaling to displacement of water will be thickness of water into 1 minus 1 out of refractive index of water plus thickness of the liquid, displacement of the liquid, into 1 minus 1 out of refractive index of the liquid plus displacement of the glass will be thickness of the glass into 1 minus 1 out of. So to get the total displacement, we look at displacement that will be caused by this, by that, and then we sum like we are adding to get the resultant displacement. So that will be equaling to thickness of water. Water is of thickness 3 into 1 minus 1 out of refractive index plus thickness of the liquid. The liquid is of thickness 10 into 1 minus 1 out of refractive index of the liquid 1.43 plus thickness of the glass, which is 8 into 1 minus 1 out of refractive index of the glass. And now here you are supposed to get your calculator and you can compute slowly. You can compute slowly. We are having that. this one here is going to be 0.74436 plus, I can work it out one by one, 1.45 to get that, and 1 minus our answer, and then times 10, that is 3.1035 plus 1 divided by 1.52, and then I'll get that, and then this is 2.73684. And if I first confirm this one here, and I see so it's that, and then plus 3.10345, and then plus 2.73684 to give me a value, to give me a resultant value of 6.5846.5 centimeters. But please, this is displacement. Their interest is find the apparent position of the mark below the tank. Where will it look like? Apparent depths. Okay? This one we have calculated, if it is 6 point, that means that it will appear to be somewhere here. It means that our object, our image, will be somewhere here at some distance, which is 6 point, these values here. Okay? That is displacement. So if we are to get the apparent depths, they need now this. So our apparent depths will be equaling to the total depth minus the displacement, which will be 3 plus 10 plus 8, total depths. And then subtract away displacement to remain with apparent depths or apparent position minus my 6.58465. So basically that will give you 21. Okay? That is 21, subtract away 6.58465. And you're going to get here your 14.415350 centimeters. So the apparent depth or apparent position of the mark below the tank will be equivalent to 14.4135 something like we have calculated here. So that is how you can handle this kind of problem.